All right, so this is a problem from 8.3 y'all about the partial fraction decomposition. So let's see if we can't figure it out here. Okay, so we have two factors, right? My denominator, one of them is a linear factor, and this is one of those irreducible quadratic factors, right? So remember, my denominator is going to look like this. We're going to have two fractions. One of them, the denominator is going to be x minus 2. The other one is going to be x squared plus 2x plus 7. Okay, so since this one here, the first one here, is a linear factor, my numerator is just going to be a coefficient. And then, since this one here is quadratic, then my numerator is going to be a linear factor, right? So it's going to look something like that, bx plus c. Okay, so now that we have that, remember, step number one says let's multiply everything by the common denominator. And our common denominator is x minus 2. That looks like a plus, so let's fix that. All right, let's see, x minus 2 and x squared plus 2x plus 7. So this is all sort of together, right? Okay, so we're going to take this piece and we're going to multiply it once, twice, and 3 times. Okay, so we know the first time we do this, all of this business here is going to cancel with each of those. So I'm going to end up with a 6x squared, there we go, minus 3x and plus 12. And when we multiply it by this part, we know the x minus 2 is going to cancel. So I'm going to have an a times x squared plus 2x plus 7. And the second time, this one is going to cancel. So we're going to left with a bx plus c times the other denominator, which was the x minus 2. Okay, so now I'm going to go real slow here. I'm going to distribute my a. So that's going to give me an ax squared plus a 2ax plus a 7a plus, okay, now we're going to start filling this out. So that's a bx squared minus a 2bx plus cx and then minus 2c. Okay, so now let me see if we can kind of put some stuff together. So we're going to do a little stare and compare. So I know here's my x squared, and we have an ax squared and a bx squared. Okay, so now let's take a look here. So I'm going to do this on the next slide, y'all. So this is going to tell me 6x squared is equal to ax squared plus bx squared. Okay, and then let's see. The next part is a negative 3x. So a negative 3x is equal to, I'm going to come back and look at all the ones that have an x. So we have a 2ax, a minus 2bx, and a plus cx. So 2a minus 2b plus c. So 2ax minus 2bx, and then plus cx. All right, and then we have one more. So we have, let's see, we'll go red, 12. So 12 is equal to, let's see, I'm just looking at the parts that just have no x's. So 7a minus 2c. So 7a minus 2c. Okay, so now that I have this part here, let's see if we can write out our equations. So it looks like the first one is 6 equals a plus b. So 6 equals a plus b, right? And all I'm doing is kind of getting rid of the x squareds. And then negative 3 is equal to 2a minus 2b plus c. 2a minus 2b plus c. So this will be a minus 2b plus c. And then 12 equals 7a minus 2c. 12 equals 7a minus 2c. Okay, so I'm looking at this thing here, y'all, and we're going to figure out what it is we're going to cancel out. So if we were to take, say, this second equation here, y'all, and we were to multiply it by 2, that's going to give me a negative 6. 2 times 2a is going to give me a 4a. So that's going to give me a minus 4b, and that's going to give me a plus 2c. Now the reason why I'm doing that is if I add these two equations together, that's going to give me a 6 equals 11a minus 4b, and then my c's cancel, right? So now I can take, say, this equation here and this equation here, and I can eliminate one of those variables, whether we eliminate a or b. We'll do that in a second, okay? So let's take a look at the first equation. It's 6 equals a plus b. So 6 equals a plus b. And the second one is 6 equals 11a minus 4b. Okay, if we take this top equation and we multiply this by 4, that's going to leave me with a 24 equals 4a plus 4b. Now, if I take these two equations and we add them together, let's see, my b's will cancel. 11a and 4a is a 15a. 6 and 24 is giving me a 30, so when I divide both sides by 15, this is going to tell me that a is now equal to 2. Okay, so we know that a is equal to 2. We can use, say, this equation right here. 6 equals a, which we just found to be 2, plus b. So if I subtract 2 on both sides, that's telling me that b is equal to 4. So notice we have a, we have b, right? I'm going to come back and I'm going to use, it really doesn't matter which equation. Say we use this one here. So 12 equals 7a minus 2c. So 12 equals 7a minus 2c. And we found that a was 2. So if I know that a is 2, this is going to give me 12 equals 7 times 2 minus 2c. So 12 equals 14 minus 2c. So when I subtract 14 on both sides, that's going to give me a negative 2 equals a negative 2c. So I divide both sides by negative 2, c is equal to 1. Okay, so look what we have. A is 2, b is 4. So a is 2, b is 4, c is equal to 1. So I'm going to come back to my very first slide. Where is it? Here we go. Right here. So remember what we said, and I'm going to clean up some of this mess. Actually, I'll just do it down here in the bottom. We said a was 2. So I'm going to have 2 over x minus 2 plus b, which was, oh my goodness, I forgot what b is, but it should be right here. B is 4. So b is 4, so that's a 4x plus c, which I want to say was 1, all over x squared plus 2x plus 7. And so this piece here is equal to all of this fun business right here, okay? It's supposed to be a plus 7.